Good day, folks. This is tutorial number 19, and I'm going to be creating a C-clamp mechanism in the 3D Experiences Release 2025x platform. Uh, the purpose of this tutorial is to show you how to use a screw joint. And so basically we have a C-clamp like this, and every advancement of the handle rotationally. So if you turn this thing by one full turn, the clamp advances and or retracts by a certain amount, which is called the pitch of the C clamp. So essentially, a screw joint is a combination of a prismatic joint and a cylindrical joint. Okay, but it's a single degree of freedom system because every rotation of the handle advances uh, the clamp by a specified amount, by what is called the pitch. Now, uh, just to put things in perspective, dimensions are not important here, but I'm going to assume that this is 12 centimeters and the initial distance between the clamp and the wall, I'll call this thing handle, and the wall is 3 centimeters, just to make things, to put things in perspective. And I'm going to assume that we have a pitch of 0.5 centimeters. So every turn of the handle will advance this thing or retract it by 0.5 centimeter. Now, of course, it's possible to do this and show it as a cartoon and looks nice, but how do we verify actually there is a physics there? So what I'm going to assume is that the handle turns at the rate of 2 turns per second. So in 1 second, it goes twice, okay? And that means that this clamp will advance 2 times 0.5, which is 1 centimeter. But then we're going to do simulation in 4 seconds. So it's going to be 4 times 1 centimeter. In other words, after 2 seconds, when we turn this thing 8 times, basically 8 times 0.5 is going to give you 4. So the offset, if we retract, it's going to be 3 plus 4, which is going to be 7. Or obviously, if you advance this thing, this is going to crash into that. You can't do that. So I'm assuming that we are retracting this. Okay. Good. Now, I will not, I will make a simplified version of that handle. So basically, this is exactly the same thing, but simplified. Now, when we try to create a screw joint, you can see here, there are many things that we have to select. So these slides, the next 4 slides that I'm going to show you, they don't mean anything until we get there when I do the problem for you. Okay. And then I will come back and discuss them. So this is the first slide. This is the next slide. So you have to select a bunch of other things. Okay. And then down here, this is where the pitch is defined. And finally, this one is something that's needed to define the axis of the motion of this C-clamp. Now, this is chapter 13 of the textbook that I did 8 years ago, 9 years ago, and it was not updated, so I decided to do these tutorials instead of going through the book and updating. Okay, good. So let's go ahead and create the assembly. All right, let's go make the assembly. So already I'm in the assembly design. So insert the wall first. This is going to be the first part. It's going to be the wall. I'm going to make it. So on that vertical plane, we'll sketch. I'll sketch something that resembles that wall. So let's go with something that looks like an L. It's about 12. This is 12, roughly 12 centimeter. Doesn't have to be exactly that. It's just that I want to have an idea how big these things are. That's all. Okay, good. Well, actually, let me make this thing 12. So here, dimension from here to here, 12 centimeters. All right, but it's just that this has to be a little bit higher. Let's move on. Exit. And we're going to pad it symmetrically, just so that it's nicer. On that top plane, I will sketch a little circle. This is where the pin is going to go through. Exit. Make a pocket here. Good. And then I make the stand at the bottom. On that plane, I will sketch. Why don't I project that circle? Okay. And exit. We pad it a little bit, maybe by 1 centimeter, and put the stand on top of it. So on that top plane, we'll sketch. Let's see now. I want to make something concentric with that. So right now, let me draw something like so, but it's not concentric. That control this middle curve, and I make it concentric. Concentric. Okay, good. Exit. And now pad it by 0.25. All right. Now we can go and make the rest of the thing. So all the way to the top, insert a 3D part. This is going to be the handle. Double click on it, and let's make it. So for example, on any convenient plane, for example, on that plane, I will sketch a circle that size. So that being the case, I'll project this instead. There we are. Exit. And now I'm going to pad this. We make it in both direction. And yeah, I'll probably be okay. A little bit more, maybe. Okay, good. So to do the rest of the stand, first of all, on that plane, we'll sketch, project that big circle. It's just that I'm too lazy. I don't. Cancel that. I just don't want to do a lot of circles and stuff like that. Project that. Okay. There we are. Exit. And pad it by 0.25. Good. And finally, the handle. There were different ways of doing it. So what I'm going to do is this. On that vertical plane, where is this? On that vertical plane, I'll sketch a little circle and then pad it. Maybe something like this. Exit. And then pad it. More. Oops. Pad it. I find it easier like that. So pad it up to surface, up to this surface. And then maybe a little bit, yeah. That's good. I mean, if you want to make this thing longer on the other side, let me see for a second. Second limit. You want the second limit, go further this way. Okay. And these are basic CAD stuff that you already know. All right, so that's this. So we have two pieces. We have the wall, basically the first piece, and the handle. Now, or the base and the handle. Now, what I'm going to do is we'll fix the wall. We are in assembly design, so we go to engineering connection, very bottom fix, and select the first 3D part. Okay, now let's do the rest of the problem. I can move things around, but it's not necessary, so just leave it the way things are. And then I'm going to make my second joint, which is going to be under engineering connection. See, you don't find screw joint here. Go to engineering connection, not the standard one here. And in the pull down menu, find the screw joint. Now, this window that you see here, dialog box that you see here is like that, and we have to start populating it. Okay, so let's worry about the first one, which says offset. Go here. All right. So we need two planes, and I already said in the slide what to pick. You pick this plane and that plane. Right now, the distance is 3.31. I want the distance to be 3, so I'm going to make this thing 3, so it's going to move things just a little bit down. Good, good. So we already did this window. Now we go and create essentially the hinge. And for the hinge, why is it plane of this? Why is it plane of that? And there are other options too. And then the axis of the handle. There are other options, such as axis at the bottom, but that's okay. I'll do exactly like I said. So, okay, we go here to the hinge. Oops. Okay, hinge. I selected this box so that it moved down to the hinge. So this plane, why is it plane? Why is it plane of the wall? Why is it plane of the arm basically? I notice that right now the angle between them is 0. And then for the axis, I select this axis. See that for this? I select that axis. Right now the angle is 0. I want to keep it like that. No reason to change it. So see, YZ axis, angle is 0 because the handle is sticking out. And then the next one, we go to the next set of things to pick, and that is specifying the pitch. Okay, I don't do this except I put the right numbers that I want in it. So it automatically puts something there which is default and I don't want it. So I want this thing to be 0.5 centimeter. 0.5. 0.5. And this thing to be 360 degrees. 360. Okay. Very good. And then I have to go to the next one, which is selecting these two axes. The last set, selecting these two axes. I'll go here. I select. Okay. Okay. So now we're going to create our screw joint. To do that, you have to go to the engineering connections. Notice that you don't find the screw joint in the list that you have here. So you click on the engineering connections and use the pull down menu to find the screw joint. Okay, let's find out. This is the same dialog box that you saw here. So first we're going to define the offset needed here. There's 4 sets of selections that we have to make. The first one is called offset, and we take the bottom of this stand and the top of that stand. Okay, so let's go out here. The bottom of that, the top of that, and it says that right now it's 3 centimeter gap between them, which is good. I mean, if you want to make this thing 5, for example, look at what happened. But that's not what I want. I want 3, just happen to be 3. So good. Then we go to the next dialog or box selection, which is defining the hinge basically. So we said select the, or I select the YZ plane of the handle, YZ plane of the base, and then for the axis, this axis. Okay, there are other choices that you can make as long as you create the hinge correctly. So you uh, put the box, put the cursor in this box so that it releases what's up there, and a YZ plane of the wall, YZ plane of the handle, and the axis of the handle. Okay, and so what I just did was to complete that portion. The third one is to specify the pitch. Okay, now that something is calculated for you, but these are default values and they're not correct. So this should be 0.5 centimeter for every 360 degrees, rotation. Now, ordinarily, look, ordinarily when you do that, look, so I just did this. Okay. The only problem is that the ratio is not calculated correctly. Okay, the ratio is not, it was not even calculated. Now, I noticed that this is a very, this must be a bug or something. Notice that you can't go and select these things. See that? So what I found out is that if that happens to you, and I noticed that sometimes it does, what I suggest is the following. What I suggest is the following. You have to do this. You have to select these two axes, but it won't let you do that. It's very fussy. Sometimes it does, sometimes it doesn't. What I found out after a great deal of frustration was to say, okay, let me delete this. Let me delete this last selection. Okay, notice that as soon as I deleted it, it let it go. Move on now. A screw joint, something was created here. Double click on it. Double click on it. That thing opens up. Okay, and uh, you have two choices. You can go to screw. Okay, and now you're gonna select this. Okay, now you're gonna select this and select this axis. So I'm sorry, but that's the way it's working. So I ended up deleting this. So it basically let me go out of this dialog box selection. And of course, because this last one was deleted, this was no longer a screw. It says user defined. So to get back in there, I double clicked on user defined and I went here and changed that to screw. This thing appears at the bottom and now I can select it. Terrible. Say okay. Notice that it is changed. Okay, that's good. Everything is done here. So we're going to go to mechanical systems design. As I said, I've noticed that this happens sometimes, most of the time. So the only way around it that I could figure out, or at least one way, was to delete that last set of selections. When you delete it, change the screw to user defined because that's missing. So I say, okay, we can close that window. Now get back to user defined restraint here, user defined joint from the tree, and then change that user defined to screw. The bottom appears, and at that point, you can select those two axis of the handle and the axis of the stand. As I said, something wrong there. Okay, so let's go and create our mechanism. Did I do it? Yeah. And then let's see what we've got here. There's a fixed part, which is the wall basically, or the base, and there's a screw joint. Okay. So it's okay. Things look good. Now, if I try to use the player here, there's two radio buttons. One of them is for the, uh, what is that? The rotation of the handle. The other one is for basically moving up and down of the thing. But this is a cartoon. There's no physics here. So to put the physics, I'm going to go to Mechanical Systems Experience. Okay, we create a simulation. Now the law is this: you go to the law excitation and select the first command right here. This is with angle. This has to do with angle, so 0 degrees. And I can put down here this 0 doesn't matter. So we put down 2 or 4 turn underscore second. That was the deal, right? Oh, 2 turns per second. I'm sorry, 2 turns per second. Let me make that thing 2 turns per second. 2 turns per second times time. You say okay. You say okay. Let's do a 4-second simulation. So I go to the kinematic scenario. We're going to create, this is the law that I created. I put it in there. Parameter, we're going to do it over a 4-second interval. And this one is going to be 0.1 so I can see it better. So basically in 4 seconds, that handle will turn 8, let's see now, 4 turns per second over the 4 turns per second. Yeah, 2 turns per second times 4 is going to give you 8 rotations here, right? Remember the physics that I put in there, it turns 2 turns per second over 4 is going to be 8 complete rotations, and for each rotation is going to move it by half a centimeter. So 8 times half a centimeter will be 4, and then the gap here was 3, so it should be at the end there should be a 7-inch gap between them. Okay, so that's fine. So say okay. Well, we can change things if needed later. So you basically compute it. All right. Now, how do we check whether it actually separated by 7 centimeter? You click on results. You go to the view scenario results. Just show me the length, which means that gap, because remember that was the offset that we requested. You plot 7. See that? 7. There was an initial gap of 3 centimeter. After 4 seconds, this thing turned 8 times. Each turn was half a centimeter. 8 times 5, 0.5 is 4 centimeter. 4 plus 3 is 7. So look, this is I noticed that this business of not releasing that dialog box happens sometimes. So what I suggested is that we get rid of that last set of selections. That means just delete this. When you delete it, this screw turns into user defined, but it releases it and it calculates the pitch, the ratio correctly. Well, at least it releases it. Then once it releases it, you go to the tree, double click on it, it puts you back here, change user defined to screw, and then select these 2 axes. Not supposed to be like that, and it's not always like that, but I've noticed that it happens. All right, good luck.